Faced with an important test of 3 new and improved atomic weapons, the Los Alamos Scientific Laboratory in the autumn of 1947 obtains the services of civilian scientists and technicians for the handling of special problems. One vital phase is measurement of blast as an index to weapon behavior. The blast measurement group is composed of experts from the Naval Ordnance Laboratory, the Ballistics Research Laboratory of the Aberdeen Proving Ground, and the Navy's David Taylor Model Basin. The Armed Forces Special Weapons Project Base at Sandia supplies a supporting element of military personnel. NOL's Dr. Hartman is in charge, with Dr. Lamson of Aberdeen as his principal assistant. The group is slated to join other scientists and members of the armed forces at Eniwetok Atoll, more than 4,500 miles from the West Coast. The Atomic Energy Commission's permanent proving ground is located in the Central Pacific, established to conduct tests in the field of atomic explosions. Here, the 38 members of the group will measure blast velocity and duration of positive and negative pressures generated by the explosion. While Joint Task Force 7 is being organized and scientists back in the States are making detailed plans for this operation, here on Eniwetok, Army engineers prepare the test site. The advance group matches technical skill against tough tropical vegetation, despite wind and dust, heat and humidity. Sweat-stained hours in the broiling sun is the price of progress. Later, the blast measurement group will work under similar conditions. In the meantime, back on the West Coast, supplies pour into port areas. Here is enough material for the 10,000 men of science and men in uniform who make up the Joint Task Force. Included is a great variety of scientific equipment, among which are instruments and supplies for use by the blast group, carefully packed by them at eastern bases. Now scientists are checked aboard, starting their long trip to the guarded atoll, slated for secret tests. At the same time, on the other side of the world, engineers stabilize the sandy soil of the Zero Islands by mixing in cement. This will reduce damage to blast instruments and aid test observation. Leveling and tamping are the final steps. Asphalt also proves highly effective for stabilization. Here it is, before and after. Engineers do the construction of the installations needed by the blast group, the blast stations on the Zero Islands, and the telemetering tower on the control island. This work is based on requirements established by Dr. Hartman's unit. An Atomic Energy Commission representative supervises the construction. But even as the finishing touches are being placed on the blast stations, the convoy is heading westward. Days at sea as the ships churn through the seemingly endless miles of ocean are filled with activity for the scientists. Below decks in the Albemarle, shop number 1 has been set up as a laboratory for the blast group. These instruments, many of them standard for blast measurements, have been modified by the Hartman unit to meet special requirements of these tests. All equipment was calibrated under shock conditions in the States. Now en route, checking and assembly continues. An audio-limited discriminator holds one man's attention, while another is busy with a blast pressure gauge, which he tests by placing in a pressure pot. Work is accomplished on measuring and recording equipment, highly important to the task ahead. A member of the Armed Forces Special Weapons Project checks an oscilloscope used to calibrate electronic instruments. The convoy has reached Eniwetok. It has been a long journey, and now the real test is to begin. The blast group assists to offload its specialized equipment. The blast station becomes field headquarters. Uncrating of equipment begins immediately. Blast group scientists hand-carry delicate apparatus to the Zero Islands. They, as everyone, must be passed by the security guard before they can proceed inland. At another Zero Island, other group personnel are among the scientists of several units who present themselves at the security gateway. The MPs check badges and identification cards. The atoll has restricted areas and the more important exclusion areas. As the scientists get nearer to key points on the test ground, security tightens noticeably. Landing craft are important in inter-island transportation, but the swiftest means of travel is the L5 liaison. On the Zero Islands at spaced intervals, instrument locations have been constructed along a radius from the zero point, known as the Hartmann line. The free piston gauge is one of the direct reading instruments, with the effect of atomic blast directly readable from a reaction on the gauge itself. Working on the line here are members of the Armed Forces Special Weapons Project. Silica gel is inserted to reduce moisture. Plaster will be used to streamline the free piston gauge. An indenter gauge is put into place. The OCE revetment is used by the Hartmann group to test shock characteristic changes that result from blast shielding. Simple 5-gallon cans are direct reading instruments. They are called penny gauges. And this, perhaps, should be called the blue ribbon gauge. More direct gauges. Blast velocity switches are installed. Tin foil is employed to shield the switch from thermal effects. All instruments are used at several points on the Hartmann line to obtain pressure versus distance data. That's it. Set to go. Mechanisms in the blast station which will receive impulses from instruments on the Hartmann line are checked carefully. Batteries, which provide power for station instruments, are kept fully charged. Antennae on the control island receive radio impulses from blast-activated telemetering gauges on the Hartmann line and feed them through a coaxial cable to the telemetering station. Here the signal will be changed to a visible trace. Receiving equipment is adjusted and calibrated. The final result is obtained on a 6-channel brush recorder. Certain aspects of sandstone photography are important to the Hartmann group. Requirements are determined for photographing the blast wave over both water and land. Such data will be of value in the group's final report, and it is by means of high-speed cameras that this data will be obtained. All work and no play is left to the instruments on the Hartman line. But the Hartman team gets in a bit of relaxation on the white coral beaches fringing the warm-watered lagoon. There's baseball and other sports often more dangerous to the umpire than an atomic bomb. From sunrise through the tropical day, Eniwetok Atoll has its scenic wonders. Despite dust, heat, and other weather discomforts, the Hartman unit sees views that almost rival Hollywood Technicolor. But now test time approaches. Last-minute inspections are made. The Hartman line is ready. Personnel are evacuated from the islands to remain aboard task force ships until the danger period is over. Scientists lead. Finally, the detonation party goes to the master control station. Switches are thrown. Final time signals are called. This is it. Accompanied by rad-safe monitors, Dr. Hartman and his associates return to the Zero Islands after each detonation. They will inspect the footings and instruments in the blast station, first step in evaluation of blast characteristics. The destructive outgoing shock wave and the powerful negative phase have left a record. Pummeled by blast, shot through with radiation, scorched by heat, the footings give mute evidence of the forces to which they have been subjected. With information and instruments in hand, the group heads back to the Albemarle for analysis and computational work. On deck, data is obtained by filling the crushed 5-gallon cans with water. The present weight will be checked against the known weight of water in undamaged cans. Group personnel analyze results, even as the convoy is leaving for Hawaii, where the final reports will be written. Graphs are plotted. Comptometers used. Micro-comparative appraisals are made. Detailed analyses take shape. Data is checked against a recorder tape. During the long hours each day en route to Fort Shafter, scientists and technicians gather their facts between moments of relaxation. Finally arriving at Hawaii, the group is taken to Army quarters. Here they will enjoy certain luxuries of civilization that were missing at Eniwetok. Now, as the group settles down to write final blast measurement reports at the Pineapple Pentagon, let's turn back for a moment and see the atomic detonations which are being analyzed. X-ray, yoke, zebra. Milestones in the age of atomic energy.